Hi gang, welcome to week 6, and here's a brief video to help you out with the week 6 written assignment, which is on quadratic and polynomial functions and also includes the second installment of algebra review skills. I think in a lot of ways from here on out Math 111 could be seen as a survey of different important types of functions. And we began after the test last week with linear functions. F of x equals mx plus b, lines, right? And this is familiar territory, but we're kind of looking at it now in a Math 111 functions framework. And we're going to continue now with quadratic and polynomial functions this week. Looking ahead, the quadratics are parabolas. Again, a fairly familiar topic that you've studied in Math 95 or in previous courses. And then we'll get into kind of sort of note how we're just kind of increasing the degree here. A linear function is a first degree polynomial, x to the first power, 2x plus 7. And a quadratic function is a second degree polynomial function, 3x squared plus 7x minus 2. Just fill in a, b, c with real numbers. And these have graphs that are parabolas. And then this week, too, we're going to generalize into polynomial functions where we're looking at f of x equals a general degree polynomial. 7x to the 5th power, or the 7th power, or the 3rd power. What happens when you go from lines to parabolas and then go to the third power functions, or 4th power functions, or 5th power functions. That's all this really is. A polynomial function could be 10x to the 5th plus 3x to the 2nd plus 7x squared minus 3x plus 2, or something like that. And the dot is in here because we just don't know how many terms are going to be in here. To look ahead at what's coming up in the course, if we continue, after a couple of weeks, this is going to be rational functions, exponential functions, logarithmic functions. So see this as the beginning of the end of the course, where we just kind of go through these important types of functions, look at their properties, look at ways of applying them in a kind of a college algebra sort of setting. But for now, the focus is, for this week, on the second and third degree polynomials, the quadratics and the polynomial functions. So first of all, your homework is going to have a section, I think it's, well, I won't say 3.2, is it? 3.3. Where we're talking about these second degree quadratic functions, and the graphs are parabolas. Some of them open up, some of them open down. That will depend on whether the leading coefficient a is positive or negative. Something you probably remember or probably learned in a previous course but really need to remember now is that the x-coordinate of the vertex, or you can also say the equation of the line of symmetry of the parabola that cuts it right in half here, is x equal opposite of b over 2a, where b and a are just taken as the coefficient on x and the leading coefficient, the coefficient on x squared in the function. And that's a very handy formula because it gives you not only the equation of this line, but it gives you the first coordinate of the vertex, and then by taking that number and running it through the formula, once you figure out what opposite of b over 2a is, just take f of that value, in other words, put it in for x, and you'll get the y-coordinate of the vertex. So this is a very quick, easy formula for finding the vertex of a parabola. And you'll see in the homework that there's an emphasis on using this information, the vertex, to solve applied problems where we're either looking for a local minimum or a local maximum, which, depending on whether the parabola opens up or down, the vertex will either be a local maximum or a local minimum. Okay, on to the stuff that I think is really truly new. Now, generalizing this to higher degree polynomials. what if we're looking at an example like, and I just used an equation rather than writing it in function notation, y equals x cubed minus 8x. That is an odd function that has a graph that looks like this. So rather than a parabola, it's got one more turning point, one more turn. Here's another example here of a fourth degree or quartic polynomial that looks like this. It kind of is shaped like an M. And here's the formula for that example. Lots of different shapes of polynomial graphs, but they all kind of have this camel humpy kind of behavior with the tails either going down or up. And one of the things that might be kind of strange, but is actually not hard in the homework and the activity in the weekly written assignment, is what's called end behavior, or sometimes informally I'll call it tail behavior. So we want to get a handle on what to expect from these graphs, and you're actually going to be able to tell based on the leading coefficient and the degree of the polynomial what kind of graph you're likely to get, how many x-intercepts you can potentially have, how many turning points you can have. And the written assignment will kind of lead you through an exploration of that. But it'll also ask you for end behavior. So how do you say in a kind of a Math 111 way that this tail goes down but this tail goes up? We're going to use something that's kind of pre-calculus, calculus notation. It's kind of like limit notation. We'll say, looking at this function, the end behavior is that as x goes to negative infinity, and just the arrow here you can read as goes to, as x goes to or as x approaches negative infinity, f of x goes to or approaches negative infinity. Well, what's that mean? That's just a fancy way of saying that the lower tail of the graph, as x gets smaller without bounds, so I'm easing my way out the x-axis, I'm saying as we look at x's smaller and smaller, approaching, heading for negative infinity, the y-coordinates go down without bound. They approach negative infinity. And as x grows without bound, in other words, as we read from left to right and x's grow and grow and grow toward positive infinity, we're moving along the graph this way, the y-coordinates rise without bound, right? They approach positive infinity. So that just says these two things. As x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. And basically the possibility for these polynomials is pretty limited. We're going to ask about x going in the negative direction or x going in the positive direction. And the possibilities are just that either f of x shrinks without bound, heads to negative infinity, or it grows without bound. And this is just going to be a fancy way of saying whether the tail goes up or down. Okay? I think that will be enough for you to get into the written assignment and work your way into kind of the properties of these polynomials and prepare for the homework. So I'm going to leave it at that. Good luck.